My particular, or Northrop's particular role, one of its roles, was to design and build the test equipment required for the mission processing on the F-35. So the F-35 has something known as the integrated core processor. It started as two boxes, ended up as one box, about this big. But it's an aluminum box, ruggedized aluminum box, with 23 modules in it. Now, those modules come in different flavors. There are modules that are power supply modules, processing modules. Like, there were two kinds of processing modules. One was called general purpose processing, and the other one was called a signal processing. There are various switches. In the F-35, the switches were fiber channel switches. And there are modules for different kinds of input-output signals. In the case of F-35, that was a combination of Ethernet, fiber channel, mil standard 1553, a whole bunch of analog signals, and a whole bunch of discrete digital signals, as well as other so-called serial signals. So in 1999 and 2000, I and a guy from the UK, from BAE, came up with the initial design of a series of so-called software development stations that would be used in the testing and verifying and qualifying those integrated core processors. And another set of test stations to do the same thing for the cockpit displays.
And the idea was, from the point of view of those two systems, they were getting actual signals so you could verify their operation?
Yep. Now, what made the F-35 different, this integrated core processor was going to have essentially all of the mission processing done inside of it. That included, for example, the signal processing for the radar, the electronic warfare, the image processing for several kinds of visual sensors, the distributed aperture system, the targeting forward-looking infrared. Now, normally, a radar from a radar manufacturer, either in the case of the F-35 was a Northrop radar from Baltimore, the radar manufacturer would have several major components that they would be totally in charge of. Everything from the antenna array to the receiver exciter to the radar processor, and the radar processor would then have a connection to some mission processor. But on the F-35, the radar processing was inside the integrated core processor.
So instead of relying on your manufacturer to give you a black box and give you data, your actual processors for everything was doing all of the computational of the raw data.
That's right.
It's a lot of load, isn't it?
The raw data came out of the antenna and the receiver exciter, and then fiber channel connection to one or two of the modules, the signal processing modules in the integrated core processor. Because of that, each of the major subcontractors, such as the radar, the electronic warfare, communications, and all of those people needed these test stations before they sent their final product to the main lab at Lockheed, where there were more test stations. So we in Northrop ended up designing and building over 50 test stations that went all over the country, and several went to the UK. So that was my job in 1999 and 2000. And in 2000, that sort of stopped, and I started working on the Pegasus program.